Hello and welcome back to the S.T.L channel. So it's been a while, and that's because I've been working on something that I feel is probably my best project yet. Even from before I started YouTube, I feel like I've really challenged myself with this one and overachieved from what I thought I could do. So in this video, I'm going to be making a custom 3D printed mechanical keyboard. So the first thing you need before actually designing your keyboard is a layout, and you can make yourself a layout on keyboardlayouteditor.com. I'll put a link for it down in the description. So on keyboardlayouteditor.com, it's as simple as choosing from a preset like layout list, or you can start your own design and just put in the keys where you want them to be. Once you've done that, you can assign letters, numbers, all the extra keys that you feel like you'll need, and it's just as simple as that really. So for my own layout, as you can see, I went with something simple. I didn't want to go too over the top because obviously it's a first time build. I also didn't want to put too many keys on there because obviously I've got to hand solder everything, and I'm not great at soldering, as you'll find out later on in the video, so I just went with the bare minimum, what I feel like would fit my needs. Once you finish your layout, you're going to head over to the raw data tab, copy everything there, and go to a new website called builder.swillkb.com. Paste your layout at the top, choose MX for your switches, change the stabilizer type to cherry, and click draw my CAD. Now, those options are up to you what you want it to be, that's just what I chose. But once you generate it, you will then get a flat design of your plate layout. This is what your plate's going to look like, and obviously we've got to then 3D model it. To 3D model it, we need to download it as a DXF, save it wherever you want it to be, and then head over to a 3D modeler of your choice. Mine was Fusion 360. Once you've imported your DXF file, of course it's going to be flat, so we need to extrude it to make it 3D. The first extrusion I did was 1.5mm. Then afterwards I flipped it over, went to the bottom, and then extruded it by a further 3.5, but made sure I didn't merge the bodies. It needed to be two separate things. Now the reason for the two separate bodies was because I needed to make a slight modification to the top portion to allow the switches to click in when I place them into the actual plate. Now I'll colour them both so I can see the difference between the two, and in a second we'll get on with making that slight modification. Now, the modification that we're going to be doing is taking the small portion here that you can see in black and doing a minus extrusion to basically reduce it by 1mm. That's on both the top and bottom of each of the switch holes. The reason for this is it leaves a slight lip in that smaller top portion of the plate to allow the switches to click in once you push them in. It gives it just that extra bit of security instead of just pushing them in and them coming straight out. So if you take a keycap off, it would just slip straight out. Now, this is a problem with hand-wired keyboards like this. If there was a PCB in the keyboard, we wouldn't have to worry too much about it because obviously the switches will be soldered into the plate. But in this instance, we have to make this minor modification just to add that bit of extra security on top. Moving on, we've got to make a cutout under each of the stabilized switches to make room for the stabilizers. The reason for this is to make sure that the metal wire underneath the stabilizers will fit in fine without popping out. It just gives it that bit of extra wiggle room to make sure the stabilizers actually function correctly. And now the cutoffs are done, I'm just going to round off the individual edges just to make it look a bit neater. You won't see this of course because it's the plate, it's the underside of the plate, it doesn't matter, but this is just personal preference, you don't actually have to do this. And now here's for the fun part, we're going to actually design the case around the plate. Now, we're going to power through this because it is long. The footage for this was quite long because this is pretty much my first time using Fusion 360 in this capacity. I've played around with it before but never actually used it to produce something. So, like I said, this is going to take a while, so I'm just going to absolutely power through it. Now, the case, I like the thicker keyboard cases. I like the big bezel around it. Not necessarily the height. You'll see in a bit that I feel like I went quite high on it because I was worried about the clearance for the soldering and stuff underneath. But it looks fine, the finished product does. But like I said, the bezels was the big thing for me. I wanted thick bezels to make the keyboard stand out, to make it look somewhat premium. So like I said, we're just going to power through this. You can watch along or you can skip forward if you want to. But yeah, I'm just going to get the case designed. One thing I do want to touch on during the designing process is I decided against screwing the plate into the case. The reason for this is it makes it much easier just to take the top portion of the frame off, take the plate out and check out any issues if there is any. Screwing the plate into the case would obviously gradually wear down over time because obviously it's only plastic. Screwing and unscrewing the screws will just, wear it down. So what I went with was this lip that's going to go all the way around the inside of the case and the plate's going to rest on top. Now that the bottom of the case is sealed off and the case is one solid piece, we've got to make the frame for the top of the case. This is just to give it that little bit of extra height so that the underneath of the keycaps and the switches aren't on display, it just looks like one solid piece. To do this, I'll just make it the same width as the bottom portion of the case and just extrude it up to give you one solid frame. Now, the frame will be screwed on from underneath. Everything is going to be attached from underneath, so there's not going to be any visible screws from the outside of the case. This just gives it that extra little bit of premium feel to make it look like it's not just simply screwed together. I'm going to make the frame wider than the actual thickness of the case. It's going to cover the plate just to allow that when I screw it all in, it's holding that down in between the lip and the actual plate itself. It's just going to basically sandwich it to make sure it's secure. And I've been using the keyboard for a week or so now and it is secure. It doesn't rattle when I shake it, doesn't make any noise, so the idea worked. Of course, we're not going to leave it looking like a box, we've got to round off the edges. So I rounded off each corner of the case and did the frame to match. It just makes it that much easier on the eyes instead of just taking a look and making it look like it's just some sort of box on your desk. I know there's keycaps on the top, but you get where I'm coming from. So rounding off the edges added that bit of extra premium feel. I am going to use the word premium a lot in this video. My vocabulary, I wouldn't say broadens more than the word premium, but it does. Personally, I'd say it is a premium looking keyboard for being 3D printed. Now, I could have done this in like 100 different ways. Like, I'm pretty sure I could, but to me, this method worked and it does look good, so I went with that. Now, I do need to add a USB-C port to the back of the case. As you just saw, I made a cutout like in the lip at the back side of the case just because I realised that there was going to be too much like thickness in the wall, like the wall was going to be way too thick to even fit a USB port through the case. So I just slimmed that down a bit more. And now I've grabbed a DXF file that I found online that somebody designed of a USB-C port. I could have done it myself, but to save a bit of time, I just went online and found it. And then it was just a matter of importing the file, dropping it where I wanted it to go, and then just extruding it through the case to make the cutout. What I did is also added, as you can see, an extra outside layer to the USB-C port because I wanted there to be a bit more wiggle room because I didn't want to have to like scratch up the back of the case trying to plug the USB-C cable in. So just adding that extra little box around the outside gives you that bit of extra wiggle room. So I wanted to add a metal plate to the bottom of the keyboard just to give it that extra, again, premium feel. Because you see online people buying these really expensive keyboards and 9 times out of 10 they'll have a metal plate in the bottom, be that for extra weight, aesthetic purposes, whatever. So I wanted to add one myself. The problem with that is actually getting a metal plate made to fit my keyboard. We'll touch more on that later on. But you'll see now that I'm going to add something extra to the plate itself just to make the keyboard more custom to me and this channel itself. So what I wanted to do was add an engraving of the channel logo onto the bottom of the plate. And to do this, I had to go online and find a specific tool that somebody had made for Fusion 360 that converts images into 360 sketches for, well, Fusion 360. So as you can see, I import the image, run the tool, and it generated it into a perfect sketch of the logo. And from here, I just took the logo, made sure it was centralized, and then extruded it down into the metal plate, and it made a perfect engraving. So for the rest of the build process, it pretty much involved me just adding screw holes around the case, the frame and the plate, just to make sure that everything was secure when it was fully assembled. What I also did is I split the plate, case and frame again, all down the middle to make sure it would print on my printer, because the issue is my printer is a 256 cube volume and the keyboard was just a bit big to go on my printer, so I had to split it down the middle, so you've got to print everything in 2 parts, which is fine. It just is one limitation of having a smaller printer. Two things to note as well during the process is I added some screw hole standoffs on the back and designed the standoffs myself so that it gave some elevation in the back of the keyboard for when typing. And I also added like a diagonal lip on the side of the case just to give it a bit of extra shape. And now that the designing's done, we can finally move on to printing. I put the plate, the frame, both sides of the case and the standoffs inside their own build plates inside of Orca Slicer. They're going to be printed in a grey filament at around a 0.2mm layer height. All I'm going to do is just power through the printing process just so that we can crack on with building the actual keyboard. So the printing's finished, but I just want to touch on a few problems that I had during the designing and printing process. The first one being the switch holes. I went with the standard cherry switch holes. Turns out they were too loose for the switches that I purchased, so I just basically changed them out for some standard flat square holes, and that improved the tolerance and there was no more wiggle room when putting the switches into the plate. The other problem was the actual cut that I did down the middle of the plate. There wasn't enough structural integrity when putting it together, so I was worried that when I glued it, it was going to snap. So I basically changed it out to more of a zigzag pattern, and that adds a bit more like rigidity to it when it's assembled. There was a few things with the case as well. So the peg holes that I did circular, they sunk in on themselves so the pegs wouldn't quite fit in. Also the floor where I was going to put the weight was a bit thin, so I was worried it was going to snap. And the final thing was the actual threaded standoffs. The threads just didn't print very well, so I binned off the idea of making them screw in. After making some changes, I did the peg holes in like a diamond shape, which I saw online somebody did it because it doesn't require like supports to print them, so they don't sink in on themselves. I also made the floor significantly thicker, so it's got like barely any flex to it now as well. And the other thing is I made the standoff smooth. I also added a hole into the standoffs, took the thread off, and I'm going to basically put a magnet inside both sides so you can just drop them in and they'll magnet on. As you can see, it all fits together perfectly fine. There's a bit of a gap in the middle, so I'm going to have to like seal that up when I'm like sanding it down. But it does all fit together. The printing process worked fine, my designing surprisingly worked fine, and everything just assembles into one. But now we have to start the long, arduous process of sanding the entire thing down. I spent a lot of time sanding it because I wanted to make sure that I didn't miss any spots, it was smooth as it could get, and also make sure like the glue and the paint was going to stick onto it, because I've heard that if you don't sand things down correctly, it's just not going to stick, or the paint won't stick. But I did spend a lot of time sanding, and I feel like I sort of hit the nail on the head with it. For glue, I just used a standard super glue, put it on all the contact points that we're going to touch, and just assembled. I wasn't too worried about the glue doing all of the legwork, because the way I designed the case, it was like going to lock in on itself anyway. The super glue was just there as like an added extra layer of rigidity. To cover up the gaps that I mentioned earlier on, I'm going to be using this modelling putty. I simply just put it over the gaps and spread it over, waited for it to dry, and it pretty much went solid. And after sanding it down and doing a couple of layers, it pretty much covered up the gap entirely. You could like no longer see it anymore, so it's going to be perfect for painting. I applied the primer and the black paint to the plate off camera because I wanted to get that part sorted. I was a bit worried about the black paint on the plate being a bit rough, but then I thought to myself, well, it's not going to be visible anyway, so I didn't want to spend any more time on it. But now we get to move on to the actual painting process. So keep in mind, I've never spray painted anything ever in my life, and I decided to go for a gradient of all things. So I did a bit of research online on how to apply a gradient with spray paint, did a few practices, and thought, well, let's just go for it. And I'm quite happy with how it turned out. Watching back, like this spray painting part, I realised that I could definitely do with putting less spray paint on. So next time I do it, I will definitely apply less spray paint, but I think I was just more concerned about actually hitting every part of it and making sure it was completely covered. And there it is, pretty much fully painted, and now it's dried completely, and I've added like a glossy sealant to it to give it that extra shine and also to protect the paint. I feel like I've nailed it for a first time. But now it's time to start assembling, starting with the magnets for the standoffs. So the best way I thought of doing this was putting glue inside the standoff, putting the magnet into the standoff, and then adding an extra magnet on top and gluing it in. You'll see, it was the best way I thought of doing it to make sure that the magnets were lined up. Now this is the part that I was talking about earlier on with the lip that I put in the design. The aim was to use this sort of like thin foam sealant to go around the entirety of the lip so that when the plate's put in, it's also flush with the top of the case, and it's got a bit of extra cushion, mainly for sound dampening, so it doesn't sound plasticky when you type. And to be fair, it's actually worked very well, which I was surprised at. And as you can see, with the plate in, it sits flush with the top of the keyboard, which will then be held in place with the frame. I just want to pause right there and quickly talk about the metal weight. So before I do reveal it, I must give a huge thanks to Justway, who sent over this custom laser engraved metal weight. Justway reached out to me and wanted to collaborate with me on an upcoming video, so what better than to add something extra special to my first proper 3D printed build. Let's talk a bit more about their services. Justway is a precision on-demand manufacturing service that covers a wide range of processes, including CNC machining, sheet metal fabrication, 3D printing, and injection molding. You can upload your CAD files directly to their platform, get an instant quote, choose your materials, tolerances, and surface finishes, and have parts produced to spec. What's nice is that they support both rapid prototyping and full-scale production, so whether you're making a one-off part or iterating through multiple revisions, it's all handled in the same workflow. The backplate they sent over to me is a good example of their capabilities, clean engraving, solid material quality, and really tight detailing, which is exactly what you want for something like this. So if you're working on a project that needs properly manufactured parts rather than just prints, definitely check them out. The link is in the description. Huge thanks again to Justway for making this for me. And here it is, and honestly, I couldn't be any happier. Justway have done a fantastic job. The engraving looks great, the fit is perfect, and the best part is, after they've finished producing it, it showed up at my door within a week. So with that, let's get this fitted into the case. Now that the case is assembled, it's time to move on to the stabilisers and the switches. For those of you who are interested, the switches that I went for were the HMX Valerian tactile switch. It's got a sort of clacky, snappy sound to it, a bottom out force of about 55 grams and a total travel time of 3.4 millimeters. The stabilisers that I went for were cherry plate mounted stabilisers, and what I did do before mounting them was lube all the stabilisers just to reduce any of that extra rattle. And now for the hard part, the soldering. Before you do start soldering though, you're going to need a keyboard wiring matrix, and you can get that from the raw data that you got from designing your keyboard earlier on and dropping it into a new website called kbfirmware.com. That'll give you a wiring matrix that you can follow for your keyboard. When wiring your keyboard and following your matrix, you will notice that there are numbers going from left to right and top to bottom. The numbers from left to right are each of the columns, and the numbers from top to bottom are the rows. The rows will be connected by the diodes, which you'll have one on every single switch, and as you can see they'll be connected from left to right by bending the pin, and the columns are connected by wires that we'll be attaching later on. So a word of warning, I've never actually soldered anything on this scale before, so take what I do with a pinch of salt. Don't get me wrong, it works, but it could have definitely been cleaner. I've been using the keyboard now for about a week and nothing's gone wrong so far, but soldering is one of those things that as you do it more, you'll eventually get better at. So all of the rows are done and connected with the diodes. I've also added some wires on the end to connect up to the board later on. And now we're going to move on to the columns. The columns are connected with 24 gauge wire, and I'm making sure to follow my wiring matrix from my design to make sure I get all of the switches in the right place. So I've finished the first column, and now I'm just going to go through, finish all of the other columns and connect them up to the board. It's done, it's a mess, but like I said, take my soldering with a pinch of salt. So one of the things I noticed when adding the wiring is I didn't give myself enough clearance to glue the board down to the case. So what I had to do is muster up one of these USB-C breakout boards. It works just by plugging it into the circuit board just there, and then gluing it down to the case. As simple as that, it just extends the connection. Now I've just got to glue the USB-C breakout board down to the case. Doing it this way as well at least allows me to unplug the circuit board from the wiring, and I can just take out the plate if there's any problems at all without having to worry about the fact that I've just glued it down to the case permanently. Now, as much as I've added the foam around the lip on the edge of the case for sound dampening, I just wanted to add some extra to the bottom of the case just for that extra push. So I found this foam lying around at home, so I just cut it down to size and dropped it into the case. And after that, it was just a matter of trying to fit my wiring into the bottom of the case with the foam. Whilst I'm screwing the case together and putting the keycaps on, I just want to touch on the subject of firmware. The firmware for this keyboard was something I wrote in my spare time, off camera, just because I'd never done it before and it was my first attempt, and I didn't want to include it in this video because I wasn't 100% confident enough to talk you guys through how to make it myself. So just know that the board is flash with the firmware and the keyboard is working correctly. Now the keycaps are on, it's plugged in, it's fully assembled. It's time for a quick preview of the keyboard and of course, a sound test. And that's the end of the video. I just want to say a big thank you to everybody that stuck by me and waited whilst I was creating this video and the keyboard and getting it edited and posted. It's quite difficult to do these around my usual schedule, so I'm just sort of doing them here and there, like where I can. But no, big thank you, and hopefully we get more subscribers, more views on this video, because obviously it's only up from here. And again, one big final thank you to Justway for providing me with a metal weight. Thanks for watching.